afternoon, everybody. This is the session titled Mobile Augmented Reality for Community Engagement. My name is David, and I'll be the session moderator this afternoon for this session. We have two speakers today. I'll introduce them. The first is Saeed Amandi Olunabadi. He is a PhD candidate in the College of Design at NC State. He studies the intersection of immersive technologies, community engagement, equitable development, and active living. His research focuses on environmental justice and digital participation in disadvantaged and minority communities. Saeed has presented his works on augmented reality, physical activity, and community-based participatory research at many national and international conferences. And we're also pleased to have Dr. Perver Baran. Dr. Baran is a faculty member in the College of Natural Resources and an affiliated faculty in the College of Design's PhD program at NC State. The research has centered on urban design and planning, tourism planning, and geospatial analysis. She's worked on visualization tools to assist communities with managing their development and interactive online mapping applications. Her current research includes understanding how natural and built environments contribute to health and sustainability. So we're pleased to have both these esteemed colleagues here today. And Saeed, if you wouldn't mind, please go ahead.
Okay, hello everyone and good afternoon. As David said, my name is Saeed Ahmadi Olunabadi and I'm a PhD in design candidate in the College of Design at NC State. And I'm very pleased today to talk about my ongoing doctoral research under supervision of Dr. Perver Baran from the Center for Geospatial Analytics with mobile augmented reality for community engagement. So today, I'm going to talk a little bit about the background of my research, and also I'll introduce Augmented Reality Participatory Platform, the platform that we developed at NC State as a novel method in community engagement and participatory planning. And also I'll talk about the research and what we found. So we all love being in the streets. We walk in the streets, bike in the streets, drive our cars on the streets, or use transit because the streets actually are a very important part of our daily lives. Research shows that different features of streets, such as trees or bike lanes or sidewalks, significantly encourage people to walk and be physically active, which prevents different types of diseases. And more importantly, it makes us healthy and safe. However, in many racial, ethnic, and low socioeconomic status neighborhoods, there are not enough street features, and they do not have equitable access to those street features that make streets pleasant places. These features are necessary for walking and other types of physical activity, and therefore, many of these disadvantaged communities are disproportionately suffering from a wide range of environmental injustices and health inequities. One way to tackle these disparities is by engaging these communities in planning and decision-making, or what is usually referred to as participatory planning. Participatory planning is beneficial because it involves the preferences of everyday people in decision making and integrates their local knowledge in different phases of planning and design. Through this inclusion, participatory planning promotes the equitable development that eventually can hinder a wide range of disparities that is seen in disadvantaged communities that I discussed earlier. In general, we have at least two types of participatory planning and community engagement. Passive modes are one-way communication between decision makers and the public. Like when someone from the Census Bureau comes to your door and asks for some information, or a city publishes a report to inform residents about some new regulations or developments in the area. These are all passive and one-way modes of communication. Active modes of communication involve dialogue between decision makers and those who are or will be affected by decisions. Conventional in-person community meetings are perfect examples of these active community engagement methods in which residents can get informed and at the same time give their feedback. Both methods are effective to engage communities, but there's still an issue as many of us do not have enough time or resources to attend these meetings. Or as we all experienced in the past year or so, we really can't attend in-person meetings because of a pandemic situation, which may, who knows, happen again. One way to tackle this issue is by using digital technologies in community engagement or what is called digital participation or e-participation. Digital participation is using technologies such as computers, laptops, handheld devices, and smart technologies to collaborate on creating, analyzing, and visualizing data. User-generated content and data is at the center of digital participation. So everyone who has access to some types of digital technology can create and share information. Digital participation is very promising in community engagement as it not only saves time and money, but also expands transparency. And more importantly, it involves broader social cultural groups in decision making, those that may have been excluded from design and planning decision making in the past. One of the cutting edge technologies that has the potential to be used in digital participation is augmented reality. You probably have heard about augmented reality a few years back when Pokemon Go was introduced, and it was played by millions of people all over the world. Augmented reality supplements reality by overlaying digital information on the real world. Augmented reality enhances visualization by providing real-time and on-site information in an immersive way. So you see objects that are not actually present when you use augmented reality experiences. Augmented reality also provides unique interaction capabilities with the real world that do not need any physical or tangible touches and interactions. With current improvements in augmented reality, it's now available on mobile devices, which is called mobile augmented reality. Mobile augmented reality actually benefits from wireless internet connection and location-based services and a lot of other sensors in the smartphones. Mobile augmented reality is predominantly administered through mobile apps. Like any other app that we use, we can actually use mobile augmented reality through these apps. To use mobile augmented reality, which is very easy, we just need to point the mobile device to objects in the real world and let it superimposes digital information into the real world through the device. In our research, we integrated mobile augmented reality in community engagement and developed a novel cutting-edge platform, which is called Augmented Reality Participatory Platform. So this platform that we developed at NC State is a digital participation method that uses mobile augmented reality to engage citizens. We were particularly interested to include disadvantaged communities and low socioeconomic populations in different levels of the decision-making processes. With the AR platform, community members can collaborate in evaluating their neighborhood condition and co-produce information that can be used eventually to design walkable design scenarios. They can also vote on the walkable design scenarios they prefer, all through the augmented reality platform. So the main component of the augmented reality platform is the augmented reality mobile app that is connected to social media platforms and multimedia messaging service. Also, it's connected to a cloud database. So all data generated by the community is transferred to the database. And since they are all geolocated, they can be visualized on web mapping services in real time. So the community provides feedback, and they can choose to share their feedback on social media or via MMS, or if they prefer, they can upload it on the cloud database so it can be transferred to the real-time mapping service and can be seen by decision makers and other people. So the AR app has two modes. The COM mode, in which community members can virtually add or remove street features in the field. They can take pictures and then share them on social media or through MMS. Also, the V's mode, which enables users to experience the overall design outdoors and then vote on their preferred design and express the reasons why they selected one design over the other design alternatives. So let me briefly talk about the app interface. So this is the page in the COM mode that you can add the street features from a library of features uploaded in the app. Also, when the feature is overlaid, as you see here, you can move it or scale it up and down. Maybe you want to rotate it until you feel comfortable with its location and position. And then you can take a snapshot of the scene, which will be stored on the device memory. As I said before, users can upload all images to the database for visually presenting on the real-time mapping. As you see here, all images are time-stamped and geolocated, so they can easily be placed on that real-time mapping service. After the user captures the image, they can share the image on their social media platforms of interest with the community or the general public. This is particularly useful because it gives the platform a freedom for users to continue discussing their neighborhood issues on social media and even beyond the AR platform. In the V's mode, user can superimpose the entire design into the real world and fully experience it. They can zoom in, zoom out, see the details as much as they want. And after fully discovering the design, they can easily vote on their design by on their preferred design by simply selecting one of the smiley faces and whether they liked it or disliked it. They can also add their comments and then just hit send. So the data is transferred to the cloud database. So let's watch a short video about how the augmented reality app actually works in a real setting. Okay, so also show very briefly the dashboard for the real-time mapping. So these are, oh, sorry. So yeah, these are the icons of those features, and then these are examples of residents. That's not actual real data, but those are the pictures that the one person actually captured, and you can click on it as a decision maker and see which street feature was selected by community, and if they have any particular comment on that particular feature. So let's move forward with the research. So to talk a little bit about the research process, we have partnered with a group of communities of color in Charlotte, North Carolina, and we set up 3 community meetings and also a design charrette activity with Master of Urban Design students at UNCC and a couple of urban designers and planners in the city of Charlotte to mimic the community engagement process. After the first community meeting, in the second community meeting, community participants were grouped into 2 groups. One group worked with the AR app and through its comm mode, and the other group worked with conventional printed maps. The data generated in the second meeting were handed over to UNCC students along with city planners and designers. They played the role of decision makers and developed multiple design alternatives based on the feedback from the community. And in the third meeting, both community groups, one through the V's mode of the augmented reality app and the other one by using printed maps, weighed in on the outcomes of the design charrette. So since this study was a community-based participatory research, in the first meeting, community members identified one less walkable street in the neighborhood that was less walkable as the setting of the research. We didn't want to go to the neighborhood and ask them to do this and that, but rather we preferred to hear from the community members first, which street in their minds need improvement to be more pedestrian friendly. And community members also collectively identified community specific street features that in their mind would improve walking in that particular street. As you see here, we did this in a very conventional paper and pen way without using any digital technology. In the second meeting, however, participants were grouped into 2 groups, one working with the augmented reality app and one with printed maps. Both groups performed a few activities to identify 5 street features that needed to be added to the street or removed from the street to encourage them to walk. Participants used the augmented reality app and interacted with the app outside and through the comm mode, while the other group held an in-person community meeting. It was right before the pandemic hit, so we were able to do it in person. The community provided feedback, including what those street features were, the reasons those features were selected, and the locations in the street that those features should be added or removed. All the data from the community were given to UNCC students and urban planners and designers from City of Charlotte. I'm not going to cover that session, but they did a half-day virtual charrette and designed 4 walkable design scenarios for the targeted street, all based on the feedback from the community, 2 design alternatives based on the augmented reality group data and for them, and 2 design alternatives based on the map group input and also for them. In the third meeting, which was during the pandemic, and as you can see here, people sat with physical distancing and have masks on, both groups interacted with design alternatives and voted on their preferred design. The augmented reality group experienced the design in the field, and the map group viewed both design on printed boards. After all meetings were done, and by comparing these 2 community engagement methods, we found a couple of very promising advantages for the augmented reality platform. First, the platform provides a great 2-way communication between residents and decision makers. Community members can give feedback and input through the comm mode to decision makers about what particular street features they want to see. in their neighborhood to have a better and more walkable environment. And also decision makers can provide different design alternatives to residents through the V's mode so they can vote on their preferred design and express their preferences. My research focused on street features and walkability, but the augmented reality platform can be used to communicate with the public about any other design interventions in the built environment. For example, architectural firms can use the platform and both gather data from the public about what new developments they may need in the neighborhood, and can also show them multiple architectural design alternatives and get the feedback from the community before they are built. Moreover, the augmented reality platform is unique in providing the public to be in a place and directly interact with their surrounding environment. They can manipulate the street features or design interventions instantly, and they can place them wherever they prefer. This is very important in making more informed decisions, which after all is one of the main objectives, if not the main objective of authentic public participation. Being in a place not only provides a direct interaction with the environment, but it also creates much better intuitive visualization, particularly for novice users and lay citizens. As you see here in the left, this is what we usually see in a conventional in-person community meeting, and that's what I use actually for the map group. What you see in the right, however, is what augmented reality app provides. At the top, it is the street before the design was overlaid. And at the bottom, after one of the design alternatives was superimposed, users can and community members can see that. So the app provides more contextual data, and with the app, it is much easier to understand how the design would look like in real life. More importantly, the app provides an inclusive, accessible, and affordable community engagement method. It is inclusive because it is a mobile-based technology. We know that smartphones are the most accessible digital technology available for communities of color. And for some in particular, a smartphone is the only way to interact with the digital world. We also know that lower income households have similar literacy to working with digital technologies, including the smartphones, compared to more wealthier households. And therefore, using a mobile-based technology is equitable across the board. With the augmented reality platform, community members can fully engage in making their communities healthier, more inclusive, and definitely better places to live, and all from the palm of their hands. And with that, I will finish my presentation. And thank you so much for attending.
That's just a remarkable convergence of mobile technology, AR, and GIS. It really is. So we have about 7 minutes, although after our session here, the SIG's special interest group session started at 2:45. So we got a little bit of buffer room here if we need to take advantage of that. Mark has a comment. He says, good choice of music in the demo, in the video demo.
Thank you.
Sam's question is, what happens if someone dislikes something being added?
Okay, yes, we do have that capability in the augmented reality app with a remove button, which means that if someone, for example, doesn't like something in the sidewalk or some other places in the street, they can use that remove button and put a cross mark on that particular feature, and then they add their comments, and then the rest is going to be similar. They can share that image and with that comment. Hopefully in the future, with more technological advances in augmented reality that can actually detect objects, I think probably very soon we can add that functionality to the application, so it automatically detects that object, and then virtually it can remove it from the environment, and then the user can take a picture.
Okay. Another question from an attendee says, given the cell phone plans and data caps or costs towards unlimited data, how is this addressed with communities that are less likely to have access to extensive data plans? Is it communicated that it may use mobile data? Does
Yes.
using the app use a lot of data?
Yes. So that's a very great question, because that's actually one of the reasons that we targeted disadvantaged communities. So taking the picture itself, it doesn't need any data plan or anything like that, right? So you can take a picture, and then because it is stored in the device memory, whenever users and participants want, and they have access to free Wi-Fi, then they can share those particular images. So it's really based on their preference if they want. The important thing is, because the app itself is not connected to the database automatically, and we did it intentionally, everyone can actually run the app without any Wi-Fi or any internet connection. It's stored on the phone, and it's installed, and it's run on the phone. But when they have access to free Wi-Fi, wherever they want and whenever they want, then they can send it to the database or send it on social media platforms.
Okay. Given that this is a GIS conference, can you give us a peek behind the curtain in terms of the cloud database that you're using and how you make the web services work?
Sure. Yes. So what I use for the database is a Google-based database, which is called Firebase, that is actually connected to the phone. And then also Google Maps mapping service. We use that Google mapping service for the real-time mapping. So all those are Google services that was freely available, and we used it.
Okay. Another question from Sam. Have other cities started using this technology in planning yet?
So yeah, we are integrating this technology first in Charlotte, not exactly that technology, but using augmented reality and virtual reality for community engagement and public participation in Charlotte for their 2040 comprehensive plan. And we are very hopeful that we can integrate the technology in other cities across the nation for their community engagement activities. So yeah, I mean, we are looking actually for any other partners that are interested in using this technology for their community engagement and public participation activities.
That's terrific. We got a couple minutes left. If there's any other questions, please go ahead and put them in the chat box right now.
Maybe I can, David, maybe I can add a little bit to the last question that Said said. The current application, as Said said, is directed towards walkability and towards the street environment. So the library integrates features relevant for street environment, but down the road, if there is interest, let's say, to do something for public spaces like parks or squares, if there are other features that might be relevant, then the library could be expanded to be relevant for specific type of needs of communities. So this prototype kind of, and the research was just to show how it could be used and the relevance. So I think there is great potential down the road for using different types of applications.
Thank you for that, Dr. Baran. So we're almost out of time. It's almost 2:30. I'll just remind everyone that we have like a 15-minute short mini break, and then the special interest groups start at 2:45. And you can find those links in the attendee hub. And just as a reminder about this session and all the other sessions in the conference, that at the conclusion of the conference, the videos will be posted on the NCGIS Conference YouTube channel. So just go to the YouTube website and search NCGIS Conference, and you'll find the recorded sessions for this conference, and also our previous conferences as well are also on there.
So once again, I'd like to thank Dr. Baran and Saeed for their presentation today, and all you attendees for attending, and have a good rest of the conference. Thank you very much.
Thanks, David, and thanks all for
Thank you
attending.
all. I appreciate it.